And I'm getting back to the screens.
And we're recording.
Recording. Good morning, everybody. This is the first try at explanation and using Zoom, so bear with us. Fraz Frazzle, Joseph
Scalzo.
Scalzo is with us today, and will be a question and answer session. I'm going to go through an explanation of toroidal geometry in application to the Keshe flight system. And we're going to try to marriage the two ideas together and see if we can get the spaceship off the ground, or at least get people onto thinking in a three-dimensional view. So bear with us, and we're going to rock and roll. Okay. I'm going to start with a...
I'm going to mute
what am I
myself
doing?
for a second.
Okay. I'm going to get a photo uploaded and onto share. And this was the technology was like, we'll go at this step by step. Come on, give me... We're going to start with this basic design. Joe, can you see that? It should be on our share screen. When we're working with things that shouldn't fly, but yet they do, we take a look at the microscopic level. And on the wings of bumblebees and beetles, we find this shape. And I'm going to do a little bit of... Not only do we have this shape, which is like a little hair, it's kind of a carbon-based form. It has the shape of a rook on the chessboard in a little bit. It just gives you an idea what kind of a three-dimensional view of this two-dimensional drawing. In addition, they have these domes all the way around it interspersed. So there'll be hundreds, millions, thousands per square inch of these shapes. And what happens is the insect develops lift by setting up what we call toroidal fields. Erase all. And that forms in that location, which immediately, and it has a rotation to it, one way or the other, doesn't matter, comes in it starts another rotation simply as a vortice. It just one interacting with the other sets up these toroidal fields. And we're going to stay in two-dimension right now and just look at these circles. So one is moving in that direction, anti-clockwise, let's say, which causes the second one to rotate clockwise. That's your second field interaction, which immediately starts the third one right here in an anti-clockwise direction. Why is this important? Well, we take a look at this one, which is 1, that one, which is 2, and that one, which is 3 in numbers, is actually exponentially greater. It's a multiplier. We start with a smaller toroid field here in number 1. We go to a much larger one in 2, and we take a look at what is the volume of a sphere, and it doesn't increase by 1 by each inch. It's like 3.14 pi as a multiplier. And then we look at the next one, which is the third one right here, and that's an even bigger one. So we have a little one, a medium-sized one, and a large one in this structure. Then the force that comes off of this causes lift. At this particular point in my understanding, I do not know whether that lift force is that direction or that direction, but it causes lift. experimentation will follow, so we'll figure this out as we go along. The information I'm presenting is what I know as of today. It may change tremendously as more of you take a look at this and say, oh, you're missing a point, Praz. That's perfectly okay. I am up for any comments that people might have and their understanding, because I'm looking for the aha moment, and maybe we can move this forward. Won't erase it all. So we have a vortice here and a vortice here. And so on one side, it is clockwise on a half and a cross section. On the other side, it's anti-clockwise. The same thing with the one below. If that one on the right-hand side is clockwise, the one right below it will be anti-clockwise, meaning that the other side of it will be clockwise and the opposite direction and the opposite direction. So realize that not only is this two-dimensional, it is three-dimensional, because the centerpiece, let me change color, in the middle here is like the rook on your chessboard. And these red vortices on the outside go all the way around it like a donut. Why is this important? And we'll go to clear this one and go to the next image. Share image, going for another photograph. A lot of what's on the second one is going to be similar to the first one. It takes a minute for it to load up on my machine. We have these toroidal fields forming at the top, and I've got them indicated in orange right up here in the top in red. Ooh, erase. If we looked at the bottom, now in the B, those are domes underneath this, surrounding them. We go to another structure which is similar, but the inverse of what the bees and the beetles have, which is a golf ball. Those are divots all the way around. And the reason for that is the golf ball doesn't have that centerpiece in it. It would be a hairy golf ball if that was the case. And every time you struck the golf ball, you would be damaging those carbon hairs on it. And but if the golf ball had those carbon hairs on it, they may have to change the size of the golf course, because instead of having just the lift because of the dimples on the golf ball adding, as it spins backwards, it causes the ball to lift while going through the air. Having the hairs on it may quadruple the distance that golf ball would travel. And this is the premise that I'm going on for the next part of what we're going to be explaining today. Okay, erase all. Let's see. We're going to go to the next drawing. It'll take a minute for it to bring it up. In the infinity, which picture am I going to be able to use? Let's see if that'll bring it up. The infinity project is using this symbol. It is basically a wire that is, change color to blue. We start with a wire. It's wrapped onto this one, has a couple of twists on it, goes up to the next one, has a few twists, comes around. These are twisted together, comes back, twisted together, comes around and out. That's your, basically your infinity loop. What happens is that these intersections, depending on the number of twists and stuff, causes a multiplying effect between one end to the other. And what we've demonstrated to date is that both of these wires basically act as one coming in, goes through the loop. You have a field that generates that's in this direction. So to keep people from getting all weird, strange out on this, this ends up being our minus side and the upper, the positive, but it's coming in at the bottom and transmitting out the top. It's this toroidal field that gets set up, but it works very much like an antenna. So if this is the bottom where the two ends of the wires are lastly connected and you have this tag end at the end, or if these wires are wrapped up around it, the force comes in at the bottom, plasma force, and goes out at the top, just like antenna works. If you want to reverse the process, you turn the whole system upside down, just reverse it, and then everything that comes in would come down and come to you. So it's like you can reverse the antenna by its orientation. Where are you holding it? Right, so if this is the bottom and you're holding onto it with your hand here, then you are transmitting out. If you hold at the top, then you're receiving the energy and it's going to you. The wire still works the same, but your hand is now at that end, and this end down here is up. It works as an antenna coming to you. So it works very, very similar to an antenna. Bring up another drawing. Take a moment. Comes up. Don't tell me I didn't do that one. Okay, I'm going to have to use the one that we have. I'm going to have to draw on this one. I didn't get my preparation right. Okay. When we look at fields, let's say we have a core in this one. Come on, I need my pen. We have a core here, we have a core there, and we have a core there. This sets up an interaction. Let's use green, to where you have this interaction between the two. If that is going clockwise, this one is going anti-clockwise, this one goes clockwise as fields, and they interact. And it just goes on and on and on and on, bouncing back and forth between these. If these are all the same size and they're the same let's say, gans or their same materials, you're just going to have an oscillation and rotation that is equal. You're not going to get any lift. You're not going to get much of anything. It's static. What happens is that anything that is added in at the bottom, remember when we say the wires are at the bottom, and you add a plus current down here, then you're going to end up with an increase of the system. And it's going to be not only just the interaction between the outer set of coils going up, it is also the interaction between each one of the groups and the ones on the inside. Let me erase, change color. If you had a core or a center, maybe a pen, there we go. And that point, I wonder if I've got a pen that'll work better with that. I had it sitting here, it didn't arrive on my bench. Here it is. See if this works. Yeah, that works really well. Anyway, you have a figure 8 interaction here between the inner and the outer on this one. On the one in the middle, if you've got a coil, you have an infinity loop there, and you have an infinity loop there. If we change the size of 1, 2, and 3, and so that the top one is smaller, the middle one is larger, and the bottom one is even larger because of the sheer mass and volume of each of those, you're now going to have a multiplier. So instead of being 1 plus 1 is 2, and 2 plus 1 is 3, we go into multiplication. So we have a 1 and a 1 in there. The next one is a 2, and those two go together, and the next one is a 4. 1, 2, 4. Why is this important? We get into toroidal mathematics. On the outside of the toroid, which is what we're trying to create, the equator of it is a 1, 2, 3, 4, 5, 6, 7, 8, 9, if we're using base 10. That's your 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 1 is 4, 5, 6, all the way around. When we go to the next step, we go to multipliers, we start doing families. We have a 2, and we do 2 times 2 comes to 4, and 4, 2 times 4 is 8. Around, we end up with a multiplier effect, and that's what we're trying to set up in a 3-dimensional view, starting with a 2-dimension in the middle with these simple coils, going to a doubling of it, increasing the magnitude of force, so that whatever we put into it, it multiplies it out and increases it. The demonstration that was given to us by Mr. Keshe in the last one was if you had a little weight on a string and it goes over to a bucket, and this is 5 kilos and this is 200 kilos, and there's a little pipe that it runs through, and you spin that 5 kilo fast enough, it will cause the bucket to lift, okay? Because you are extending, you can with the pulley systems right here, every time your rope goes through a pulley, it magnifies the force, it doubles the ability, so it takes less force to lift the weight. When you were using levers, the longer the lever, the less weight it takes out here to pull here at the bottom. When we spin the lever around, we're adding centrifugal force or centrifugal force to it, angular momentum, and that force is added to that lever and it causes lift. It's a multiplier. That's all levers are, that's all pulleys are multipliers. No different than our 2, 4, 8, 16 multiplier on our toroid. I'm not getting into toroidal mathematics right now, but just keep in mind we're looking at how we multiply. Let's see if I can. So we take this idea of these 3 different sized spheres, fields. We add it to that rook design that we had earlier. And remember, we had that shape that looked like that and like so. Okay. And we're going to marriage these 2 ideas together. We have this toroid, that toroid, and that toroid. These are 3-dimensionals, not just, or a sphere. They actually go all the way around, all the way around, all the way around that center piece, that rook. The idea is for the cloraison, what the bee does is it sets up around that rook-shaped device these massive toroid fields. It does it without wire. It just, the structure on the inside basically works like an antenna, and it pings right at the center equator of the toroidal fields. This is the big one, that's the medium-sized one, and that's the little one. And it basically accelerates each of those toroids in a 3-dimensional method faster and faster and faster. So instead of having a 2, 4, 6, you end up with a 6, 36, and whatever so you have 2 or 6 at the top. Your next one is going to be 36, then 36 times 36, which is a bigger number, and a bigger number, and then that larger number is moved to the next one, which is now in probably the hundreds of thousands or a million times to 10 million times to 100 million times, which means that all you need to have is just a little pulse to start it, and 100 million times effect. Why is this important? What you're doing is you have this little bit of mass in the middle, change color. You have this little bit of mass in the middle right here. And just like your dirigibles, where you had this little furnace, or let's say on your air balloon, your little furnace in the middle, which if you look at it, there's a wrap around it to heat the gases before it comes in. You have your little gondola bucket at the bottom. You remember the bucket that Mr. Keshe was talking about that we were trying to lift? Well, that's where you're sitting, is this gondola bucket in the bottom in the thought process right now. We have air, that's the propane torch, the propane furnace that's in there is showing hot air, and you increase the volume ratio, and it's just slightly warmer, but you haven't increased the mass. You've increased the volume, but not increased the mass. What does it do? It's out here on this outer edge of that volume on the right and left-hand side. I'm showing you, it's on the outside edge that you have your interaction with gravity. Clear screen. What? It means that the big effect, if you have a toroid here and a toroid there, if you added up just the mass and the gravitational force, Earth is down at the bottom. The Earth is a great big gravitational field, and you have little gravitational parts of the mass on the inside. It's going to have a gravitational attraction because of the volume to mass ratio to the Earth. But if we increase the volume without increasing the mass, a little bit of lift, being hot air on the inside of that, causes the whole structure to raise, because now we're changing what the attractor is, and the balloon is basically sucked up into the air. It's basically that simple. The whole flight systems are based on how do we increase our volume of our container, our spaceship, our force field. How do we increase that and keep the mass constant? It means that if we're using a multiplier that is 1 to 10 million to correct the gravitational force, which is right out here, we have just a little gravitational now. We're almost lifting our balloon off the ground. It's got just a little bit of directional to the in the downward direction. It doesn't take too much more inside to cause this gondola basket to go up. In fact, in the case of the hot air balloon, we're doing 1,000 to 1 in our multiplier. When we're dealing with plasma that has no mass, we're dealing tens of millions of 1 in the multiplier. So that when we're just about ready to lift off, if we've got the slightest lift in the line of, we're feeling that if it was in a car unit, you'd say, oh, it feels like I'm on ice. I've reduced the, my car doesn't feel like it's as heavy. Then it's only going to take a thought to go up to give you the lift, because you're multiplying that thought energy, that simple photon of thought energy, 10 million or a billion times more. And so you have, just simply by your thought, enough energy to have the levitation, to have the lift. How do we get this to happen? Well, it's a matter of setting up our exciters to the toroids. We're not doing it with wire, we're doing it with a ping in the middle. The infinity loop in the middle and is the first key to the system. When we build our core in the middle, what we want to do is to ping, change color, the center equator of this new larger toroid. At first, we'll be using small voltage, something in the line of 0.5 to 3 volts. It's something that you can easily build with your plasma batteries. It sets up the core accelerator in the middle to ping the invisible toroid field on the outside. And how we set that up is to set up very similar to your magrav coils, your stacker coils, your flat ones. But instead of having one on the middle, in the middle, and one on the outside, I'm going to erase all now. And let's go to the next drawing. 1 second, we'll stop that one. And we'll go to the next photo. Take a minute for it to come up. All I've done is tipped Mike's infinity. All I've done is tip Mike's infinity loops sideways, just giving them a little tip. I've modified the shape of them. And so the top one is going to be, one end is going to be smaller, the middle one is going to be larger, and the bottom one is going to be even larger. That's the cross section. We're going to go 3 dimensions, and remember that we are dealing with the inner magrav coil of the stacker unit, not the double. Each of your magrav coils has an inner coil and an outer coil, and the inside of the inside is actually 2 springs, and the outside one is 2 springs. Okay, we're just going to be using the inner double spring at this point. So we have a core in the middle here, and a core in the middle there, and that magrav is actually a complete circle, and I've just got it cross section, so that's just half of it. If it's 3-dimensional, it's all the way around right here. Okay. We take the second magrav, that's one at the top, that's the little guy in the top, that's the one. The number 2 magrav coil is the next one out, which is your larger, it's the outer double spring. So it has, this one has a little core in it, that one's got a little spring core, this one's got a little spring core, and that's a little spring core. We will be making a 3rd set of double spring magrav cores, larger. And this one is in proportion, so this would be the same numeric if and I'm using base 9 so that everything, when you get through with a number of coils on the number of windings on your spring, it adds up, it reduces, the number reduces back to 9. So if it was 12, it'd be 1 plus 2 is reduces down to 3. So it's the 1, the 2 becomes 3, reduces, that number is 3. So it's no longer, a 12 is equal to 3. In 17 would be 1 plus 7 is 8. So 17 reduces to 8. In your magrav coils, where we want all this number of coils to reduce to a 9 when you add them all up. Some of them have been doing something like 87 for the small one. Wait a minute, 81 I should say for the small one. 126 for the next one, and the next one would be something like 342, just for grins and chuckles, so that you have a progression in size. Don't take these 3 numbers as gospel, okay? You just want a nice progression in size so that you start with little ones at the top, medium-sized ones in the middle, and larger ones at the bottom. You will find that there will be a progression when we finally get this figured out that will be optimal. But for right now, just we want to have that 9 number as part of the core. 9 is your constant in the toroidal mathematics. The interaction, if you do a cross section, so, and I'm going to change color. It comes around like so. Comes around like so. It's not just 2-dimensional, because remember this is a cross section. It's 3-dimensional. It's all the way around. Plus you have the infinities in the middle of each one of these. These are multiplying. And these are multiplying. And the overall is multiplying. Okay? And this sets up a larger field on the other side. If the charge is going one direction, the field is going one way. You change the charge the other direction, this changes the outer. This is your up and your down. Remember, your core is in the middle. That's what's so. Your core is in the middle. It's at rook. Your magrav coils are on the outside. One there, one there, one there, one there, another one there. These are doubles. The new color. If we add a current, a plus and a minus, into this area, it's going to set up another interaction on the inside. So you have, erase all. You have the one coming on the inside, one way or the other. You have the infinities here, 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 you have the interactions there, okay? And these are getting larger and larger, and you're getting this massive one here, to the point that this whole structure is filled with a small unit on the inside, in the middle. Small, this inside, this little, very similar to the furnace on the hot air balloon, is filling up this whole volume. We're increasing the volume, but we haven't increased the mass. In fact, there is absolutely no mass out here that we're adding. But this big toroid on the outside, because of its electrostatic charge, has the appearance. Go to, oops, I lost it. I lost my pen. There we go. It has the appearance on this outer boundary just the same as the outer skin, and I'm going to do it in green, as a Granny Smith apple. Okay? That becomes the container, that outer skin becomes the container of the field. And it's just because it's an electrostatic, it doesn't have to be physical. The red area in the middle, this next section, which is this area in here, would be the flesh of the apple. This is your plasma field. This is your toroids that are going in here. And the inside, the spot right here where that little rook is, right here in the middle, this little rook, that's like your apple core. Now you can make a field the size of an apple with this, or you can make a field the size of a football field, or a football dome, you know, that encompasses the field and everybody inside. It's that big. Why is this important? If you have a charge on the outside, let's say it's a EMP pulse, it can't interact with the inside. It can only go around it. It's just like it hits a bubble and it goes around the bubble. If we get it set up right, you could have this, it could be raining outside, and it would be dry on the inside because the force field that's been in the plasmatic force field is pushing the rain away from you. So this could be your tent. This three-dimensional toroid field is your tent. This is the beginnings of the understanding of the lift. Now, it's quite possible that when we get to the understanding of that rook piece on the inside, we may have it right now for our demonstration and our talk today. We may have this upside down and we may have to rotate it the other direction. So the tip is down. But let me talk about this center real quick. If we take our center piece that we put on the inside of this rook, and we put a bead at the top, and it sticks out, this is just like an antenna in design. It comes down through, and at the base, we make that ground. We now have a receiving antenna. The outside information comes in, is received by the antenna, and it's above our toroid field that we have in. The antenna is up a little bit, and this is just at the edge of my understanding, so bear with me. We have information coming in from the outside, comes down, and it can be photons, it could be electrons, it can be information, doesn't matter. The signal comes in the field, and it goes to ground. This is exactly how your FM antenna or your short band antennas work. With your coils around the outside edge, the signal comes in, goes to ground, and these coils harvest it, and that goes over to your radio. Okay, it's a radio circuit. Your whip antennas with a coil at the bottom, you're not taking the information directly from the center coil when you're hooked up your CB radio. Your pickup coil is on the outside, around the outside. It's just a sphere around the outside, and then that wires go to it. And on the top side, if you want to transmit, or if you want to receive, it comes in this way. If you transmit to the bottom, and it sends it back out. Erase all. So we have an antenna going to ground. Won't drop anyway. It goes to ground. We're setting up. It's the same thing. We haven't changed anything. It's the same principle. It's just, what do you want out of it? What is the dynamics? This is a dynamic core, and as long as you keep inside the fractal, it still works. If you want to stop, you break the number, you get out of the fractal progression, and it doesn't work. Keep inside the fractal numbers, the system works, turns it on. Break the fractal code, it shuts it off. It's an on-off. It's a binary process. It either works or it doesn't work. The antenna idea is really important on the next one. Is that we have the antenna, which is that little hair on the top of the rook. we put our ground at the bottom. This ground could be a actual earth ground and have it connected to earth, and the static charge goes through trying to get to ground, goes through it, and these coils are all pickup coils going to whatever you want, whatever appliance, fan, radio, or something like that. Antenna going to ground. If at this time we decide that we don't want to use an earth ground, an actual physical earth ground, we can do an artificial ground at this location using lead or lead gans. Okay, it's still the electrons and stuff, everything still wants to go to ground. We just provide an artificial ground. This artificial ground becomes the center, the end of your spaceship. It goes into your car units. In your car units, your artificial ground is your battery because it's got lead in it. Okay, it's your lead gans in your system is your artificial ground for your spaceship. So where you put it becomes super, super important. It doesn't belong up in your coils. It doesn't belong in the center of your reactor. It belongs at its place, which is at the bottom of that accelerator. It is where it's going to go to ground in this example. Okay, I'm going to then go to the next idea, and I'm going to go back to the infinity coil. Take a minute, bring this one back up. Let's see if I can totally confuse everybody. And this would be 1/2 of the system. But if you have your just a cross section and a half of that cross section, remember in your infinity coil, we get the colors up. We have wrong color. We have we set it up with a, give me a draw. There we go. We have a core in the middle. We have a core in the middle. And we have a core in the middle. That's your center wire, your center spring. We have an outer spring. We have one here. Draw. An outer spring. Outer spring. Outer spring. This sets up an interaction between the magrav, separate magrav coils. Hope I've got it. Like so. We set up next a battery on the outside. Let's see, how do we want to do this one? And this is on the outside. And we set up our, change color, on the inside, our rook. On the inside. Okay, now on the inside of our rook, we have an antenna. Do a different color. Goes down through the middle. and it has a ground. It has a little bright spot at the top. Wait a minute, where's my drawing? Okay, we want color. Pen, color. Remember, we're gonna pretend that we're transmitting out of the top right now because we got tip, and that's going to be transmitting out at the top. It's going to be broadcasting. And wiring schematic. Get another color. At the top of our battery is a plus, and the bottom of our battery is a negative. And we run, for the sake of example right now, a wire out and over, around the antenna, and back out to the minus. In the battery systems, when you're dealing with a plasma battery or an alkali battery, you're actually moving electrons from the minus to the positive. Okay? The battery charge is that way. Because of, it goes, the result is that the plasmatic charge, change pen colors, is that way. So to make the antenna transmit, we would have to flip our battery because it's going the wrong way now. So the positive becomes at the bottom and the negative at the top. Your current, change color, now goes that direction because it comes from the minus to the top, and it changes the inside of the antenna, so it goes the opposite direction. We've changed direction by changing simply what the battery does on the outside of the system. The wires don't have to go over the top. I'm just trying to keep things in orient. This isn't an actual wiring. This is a schematic for understanding. What we're doing is we're transmitting out of the top. We're expanding the bubble. The effect of this on the electrical circuit is because you are discharging your electrons from the top of the antenna, this sets up your dynamic circuit, and this stimulates the coils, and you have an interaction not only inside an infinity here, here, and here on the 1, 2, and 3 on your coils. You now have a interaction between that coil, and that coil, and that coil, and you have an interaction between that blue coil and the center one, and all of these have an interaction with each other, and the whole thing causes an expansion, rotation of a huge plasma field. We're actually expanding our plasma fields thousands and thousands and thousands of times in volume and space by using, clear everything, starting with our basic infinity symbol here, or infinity idea, adding it to our rook in the middle, adding our antenna to it, adding the charge from everything. We are taking all the pieces that we've been building for the last year and putting them into one unit, which is the flight system. The piece that Joe and Mike have been working on together, erase all, is the rook. That's the center core ping. That is what accelerates everything, but they have to be in the right orientation. Okay, I'm going to open this up for questions now. Okay, Joe.
Wow. I don't even know where to begin. Wow.
Isn't that, I mean, it took me 3 days to put all the pieces together. It didn't come together until yesterday morning about 6 a.m. and I went, whoa, I've got to talk to everybody. And I had a chance to spring it on Zane yesterday afternoon, and it was like way too much information, way too fast, and he's like going, I don't understand. But that's okay. I wanted to bring Mike and I wanted to bring Joe in on this. I got Joe right now. So, what do you think?
I think you gotta get a hold of Cleve and get a software kit and get these drawings out and start. My mic is going crazy.
Okay.
Can you hear me now?
I can hear you. Yeah, you're breaking up a little bit.
Yeah. Well, we need to get this out in a 3D drawing. Have fun.
Yeah. Now, do you see that core you've been working on? The Coca-Cola bottle caps, the coil on the inside, the antenna through the middle of it?
Yes.
That center of that unit has to have your CH3 gans. It's got to have your iron core. It's got it. That's your ferrite core. Okay?
Yes.
The wire that goes through the middle at the top of it, I'd bend that son of a gun over just like we did on the ends of the health pans at our wiring junctions when we were building a simple bend over would just bend the end over would do it. You could actually put a BB on the end of it, a knob on the end of it. That's fine. The other end needs to go to a ground, and we can do a simple gans of lead at the one end and the knob at the other, so that it's basically an antenna. It's a pack around unit. You could put it in your backpack. You could put it in your car. You could put that thing in the middle of a football field. It's your mobile pulse. The outside of you've got your center wire down through the middle. You've got a coil around that is nano coated. The center of it has the CH3 gans in it. The caps are in place and are it's sealed up so you don't spill anything. It's all glued up. It's all perfectly okay. The outside bottom has the lead gans on it. Around the center of that puppy could be spheres of gans of your choice, and I would look at the CO2, the CuO, and the CH3 possibly around the outside, and those have the wires set up like Zane and I were working on in our car units, so that you're basically they're like capacitors, but they're they're sitting on the outside. There's a pickup and a discharge on them, a plus and minus, and the bottoms are all hooked together in a circle, and the tops are all hooked together in a circle. Then your plasma batteries go around the outside of that, so that you've got 3 plasma batteries in the middle, because when we start looking at our toroids, there has to be a gap in it to allow things to happen. You can't have everything can't be one circuit or one mass. It has to have gap spaces in it, separations. And then that unit in its entirety goes inside the coil. So instead of having the battery pack on the outside, because you're using plasma batteries, they can go on the inside of the magrav coils. We have no wires going into it. The only thing that can control it at this point, when you do that, I mean, you can actually lose your entire spaceship by assembling it that way without your either amino acids in the CH3 in the middle, or your amino acids out in the CO2, or you have to have the connection, because this son of a gun is going to be controlled entirely by your connection to your mind, and that is going to be either through the blood in the CH3, or it's going to be the lymph type things like your gans of urine and that kind of stuff mixed into the CO2. So everything has to be in place. The inside has to have a connection to the outside of everything. So it just keeps building and building and building, staying inside the pattern matrix of the toroid. The control then for your spaceship is the DNA on the inside. So each one is personal. Each spaceship is personalized. It doesn't mean that you can't carry a bunch of people in it. It means that the driver has to have the connection to the drive engine. Okay?
Yes.
It's like, it is so, all of a sudden, when you put all the pieces together, when you finally get it all together, it is so bloody simple, it is pathetic, at least on paper. But if you break pattern, if you have the parts scattered around, it doesn't work. It doesn't work at all. It's either on or it's off. It's either in pattern or it's not in pattern.
Well, we all knew that we were very close. But we didn't know how close we were. Really amazing.
Does that do I get an aha moment from you on this?
Oh, you did get an aha moment. I was muting the cameras off, and I'm like, wow. You get a wow. Yes.
I think from start to finish, the concept, I think, is there. Now it's just a matter of applying the concept. I was realizing that we had a problem with our car units. Number one, that our car unit was being mounted incorrectly in the vehicle. Most of the folks are mounting the car units horizontally when they need to be mounted positive vertically, so that the CH3 is at the top. See, and setting up the progression in this 3-stacker toroid that I've got, we're probably looking at lacing the top part of the toroid pingers with more of the CH3, going to more of the ferrite portion of it. I realized here a few months ago that when we got into the I just went brain dead on this one. That circle circuit that you showed me, and you said everything is the jewel ringer. The jewel ringer was the key because they only put the ferrite in one spot a lot of times. It's all they needed because they're just pulsing the toroid field around it. It's getting it in motion. That's where the free electrons are at, but they got to go someplace once they get them moving. And so it's a doorbell circuit. It's a step-up transformer, step-down transformer. It's the setup for your antennas. The jewel ringer circuit is like in everything, but it's never been applied as a lift item. And when we take a look at Mr. Keshe going, you guys are playing with some very dangerous stuff when you're looking at that hadron collider. Look at the size of that ring. Look at the size of the ferrites that are inside that ring. Look at the amount of energy that they are applying to the outside of the ring. The only thing that's keeping them from causing a problem is that they're adding it out in the outside ring. They're in the addition, the 1 plus 1, the 1 plus 2. They're going to get it right here pretty soon, and it's not a good thing. They're sitting on a friggin' time bomb ready to go off. And what I think has happened, and I'm pretty certain that we're not really worried about it, is they burned a hole through the middle of their toroid. That was the steam going off in Lake Geneva, that water spout that formed. They burned a hole through the side of it. So it's broken, but they don't know it's broken. We're looking at something that is it's a multiplier of not 2, 4, 6, 8. 2 times 2 is 4 on up. But we're looking at the multipliers that will get you to million times, 10 million times on a ping, to the point where all you're doing is the simple notion of a thought is enough energy. Your field, your plasmatic field as a human being is enough energy to drive starships and galaxies. That much. Pretty amazing, eh?
Yes, he was 7 in math. He was showing a long time. I'm such a bad feedback here.
Okay, let's shut this one down and send it off to Cleve and get it into the 3D modeler.
Okay.
And go from there. And I'll chat with you guys later.
Okay.
Okay.
Thanks, Finn.